Alright, so in this example problem we have a monatomic gas at an initial pressure of 1.01 times 10 to the 5 pascals. And we're told it expands adiabatically from an initial volume of 1.5 meters cubed, and then its volume is doubled, which is going to mean that it's going to go from 1.5 to 3. And we want to know what the new pressure of the gas is. Now there's a couple of keywords we need to focus on in here. The first is the fact that it's monatomic, which is going to tell you some information about the constants. And the other is the fact that it's adiabatically expanding. Whenever we have something that's going through an adiabatic process, there is an extra relationship that we can use, which I've written down here, to go between different pressures and volumes. So the first thing we need to find is the adiabatic index. Adiabatic index is found by taking the ratio of the molar specific heat to constant pressure to the molar specific heat to constant volume. And because it's monatomic, this is your molar specific heat to constant pressure. This is your molar specific heat to constant volume. Now, what I've written below, I've canceled out the R's, I've canceled out the 2's, so that the adiabatic index is 5/3. I've then plugged into my relationship here. I have pressure. I have the initial volume. Only the volume is raised to the 5/3. I have the second pressure I'm trying to find. And then remember, this doubled, so this is now 3. I've also now raised just that volume to the adiabatic index. And then I am able to solve for my pressure. Now do be careful. I used a fraction as my exponents. If you actually do that 5 divided by 3 and use the decimal form, that's going to change your answer just a little bit because, of course, when you write that down, you're rounding a little bit. So do be aware of that.